Yes, good afternoon to all. In the previous lecture, we have covered normal forms, that is Chomsky normal form and the Greivak normal form. So, in normal form, we learned that a context-free grammar is given to you. Then, simply, you just convert the grammar if suppose in only a terminal, or if suppose there is only two variables, then we can say that particular context free grammar is in Chomsky normal form. So simply this is the rule for CNF, Chomsky normal form. Means if anyone asks you to convert the grammar in Chomsky normal form, then you must convert all the productions of the grammar in that form. So simply this is the Chomsky normal form. Now there is another one, another normal form was, that is the Greivak normal form, that is GNF. So in case of GNF, all the productions must be converted in the form of A to A alpha, where alpha is what? Alpha belongs to Vn asterisk, right? Vn asterisk. So simply you can see here, in this case you can find this one. This means that a to a alpha means a is what? This is the terminal, and alpha is what? Alpha is Vn asterisk, means any combination of the variable. Means if you see the Chomsky normal form, then you can find here that here the length is restricted because only two variables are allowed, right? But in this case, variable the length of variables are not restricted. You can use any number of variable on the right hand side, but the restriction is initially you must have the terminal. This is the important point here. Initially you must require the terminal. शुरुआत में आपका टर्मिनल होना जरूरी है. So this is the simple point of simple normal form of Greivak normal form. This is the simple rule of Greivak normal form. So we have converted all the context-free grammar in the form of Chomsky normal form as well as in the form of Greivak normal form. Now, let's start one new topic, that is the context-free grammar to PDA. That means you can say here this is the equivalence of PDA and context-free language. So the meaning is, if a context-free grammar is given to you, then you can convert it, or you can find the equivalence of that grammar, that is PDA. So as we know that PDA is the automation or the automatic machine that is used to accept a context-free grammar, right? So now we have to we have to give a relationship between this context-free grammar and PDA. So means if context-free grammar is given to us, then we can convert it in the form of transition function, because in whenever we talk about the machine, then the execution is explained, or execution can be displayed with the help of the transition function. If we talk about the grammar, then in this case the working or the execution is represented by the production rules. So now if we talk about the equivalence of these machine and the grammar, then we must have some relationship between the transition function and the production rule. Or simply we can say we must establish some relationship between production rule and the transition function. So simply if we talk about the context-free grammar to PDA, that means a grammar is given to us, that means production rules are given to us, right? Just we have to convert the given production rules in the form of transition function. This is the objective actually. So how can we perform this transformation from production rule to transition function? So just see here, if we talk about the grammar, then we know that grammar can be represented by using 4 tuples, right? If we talk about the transition function, then in this case transition functions is the part of PDA, push down automata, and simply a push down automata or PDA can be represented by using 7 tuples, right? And the transition function delta is one of them, right? So now we have to perform some relationship between these 4 tuple to these 7 tuples. Clear? So how can we perform this relationship? Just see here, the let grammar is given as v and sigma ps, that is 4 tuples are there, and PDA can be constructed as per the given production rule, and that PDA accept language of that grammar by using empty stack. As we already discussed about the PDA by final state or PDA by empty state. So here you should notate that we are implementing PDA by using the empty stack, right? So how can we represent this thing? This is the simple representation of PDA. Now, how the main point is, or the important point is, how can we convert the production rules in the form of transition function? The important point is that, right? So just see here, there are 2 points, or you can say there are 2 rules by which we can convert the production rules in the form of transition function. So how? Just see here. In case of the production rule, there will be some variables, or there will be some terminals. Is it okay? In case of, if suppose I want to write some production rules, so simply production rules is the combination or the collection of variables as well as terminals, right? So initially, how can we have to give different treatment for the variable or for the terminals. So start just we will start with the treatment of variable. So suppose if in this case, just we are going to convert the production rules in the form of transition function. So just see here. First, we will try to convert the variables in the form of transition function. Then we will write the rule. We will discuss the rule for converting terminals into transition function. So just see here. This is the transition function. This is any state. And initially, you are not reading anything from the input tape, because at the time of defining a push down automata, or at the time of defining the transition function of PDA, then we must have 3 values here. First is the state, or you can say current state. Another one is the symbol, that is reading from the input tape. And this is the part, this is the third part. Here, this is the symbol you are reading from stack. So initially, we assume that all the variables are stored into the stack. So all the variables, just we have to write this rule for all the variables, right? So here, in this case, all the variables are stored into the stack. And in this part, this is the tape, reading from tape. In this part, you must write here null, right? And after that, we will write the transition, that is Q to beta, where A to beta is a production. Means, in this case, this A is the variable that you stored into the stack. And now, after that, you must write the production, or write the name of the variable or terminal that is produced by this A, right? This is okay? Because this beta is produced by A. That's why I am writing here beta. So simply, you must write here the variable, right? And the variable produce some terminal or variable, or any combination of terminal or variable. So you must write here that one, right? So you here, I written here, that is beta, while this beta is produced by A. And similarly, for the terminal, this is the another rule for the terminal. Suppose A is only the terminal in the grammar, then you must write here Q, that is the state, and terminal, that is read from the input tape. So here you write A, and A is in the stack, then you will write here Q to null. So simply, these are the rules that you should apply on variables as well as on terminals. So at the time of variable, just you have to follow this thing, right? Here you are just you will use null Q, that is null, and here is A. A is what? A is the variable. The same rule is applied to all the variables. So for example, suppose in any grammar, there are 5 variables. So you must write these similar kind of production rule or the transition function for all the 5 productions, or for the 5 variables. For example, in that case, you must write here Q null and a name of the variable, that is suppose B. And similarly, the value, that is Q, And here you can write the variable or terminal that is produced by B. Suppose B is producing AB. Suppose this type of production is there, B to AB. So you must write here B to AB in this way. So the point of communication is you must write all the productions here that is produced by A. Similarly, if suppose A, B, C, there are three terminals used in the production rule, then in this case, you must write this rule for all three terminals, right? For example, suppose ABC is there, A is there, then this is the production, this is the transition function. This is the terminal, this is the transition function. 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 So we have to follow whenever we want to convert a context-free grammar into push-down automata. So this first rule is associated or the dedicated for variable, and another rule is dedicated for terminals. Just we have to order all these 2 points, right? And after that, this is the part of transition function. Suppose I want to write complete tuple of PDA, then we can write set of states. So by default, Q is the state only. So this is the simply state. This is the terminal. This is the what? This is the tau. This is the transition function. This is the initial state, and S is the stack symbol. So all these are the simply representation. This is the simple representation of PDA as per the context-free grammar. Now let's start with some example also. So suppose this is a example. In this case, you have to find a PDA equivalent of this grammar. You can see here, see, grammar is given to you, or simply the grammar is what? Grammar is this one, right? So simply S to A S B B slash A is the grammar that is given to you. Now you have to find PDA equivalent of this grammar. So what we have to do? In this case, a grammar is given to you. Now, just this production rule has to be converted in the form of transition function by using these two rules. So what are the rules? You can see here, rules are very clear. In this case, just see here, what are the variables used in the production rules. So in this case, you can find the total number of variables. So here, the variables is only S. So that means we have to write the transition function as per the given rule number 1, that is you are in any state Q, you are reading null from the tape, and then just place in place of the stack symbol S, because S is only the variable. Suppose more than one variables are there, then you have to write another transition function separately. Then you can write here Q comma. Now just see what is produced by this S, because S is there. So you can see here S can be produced A S B B or A. So just you must write here A S B B, but because A S B B is produced by S, or another one is Q to A, because these are two productions that are produced by S. Is it clear? So now, next one is, this is the rule for variable, because only one variable is there. So we have completed the rule of variable. Now we have to apply another rule for the terminal. So in this case, our second objective is to find the terminals. So in this case, you can find total number of terminals are A and B, right? So you have to write two rules for the terminal. So just see here, the simple rule for terminal is Q. If we write about the A, then A from tape and A from stack. And finally, you must write here Q and here null. This is the rule number 2. You can see here, just I want to show you. This is the rule. For terminal A, then you have to write the rule Q A, that is Q null. If B is there, then just in place of A, you should write B. So it is nothing. It just you can use the same rule for the B also. That is Q B B is the input from tape, and B is from stack side. And finally, you will find here Q2 null. Q2 null. So these are the production rule. This is for variable, and this is for terminal, and this is for terminal. So total three transition functions will be there after converting the grammar or the production rule of the grammar into PDA equivalent. Now our objective is to write complete PDA. All right. So in this case, how can we write it? Just see here, as we know that PDA can be represented by using 7 tuples. So just see here, set of state, that is Q, only Q is there, right? So you can write here Q. If suppose Q1, Q2, Q3 is there, then you should write here Q1, Q2, Q3. But our objective is just to convert the production rule into the form of transition function. So simply you should use only a single state in this place, right? So always this will be Q. And here this is the terminal, right? So here terminal is what? A, B. Here A and B are terminal. Here you can note down here, from here A and B. And another one is the V union terminal. This is what? This is the part of what? This is the part of tau, because these are the symbols that can be stored into the stack, that can be variable, that can be terminal, right? And simply this is the transition function. Q is the initial state, and S is the stack, empty stack, right? And you can also write here Z0, because Z0 is the initial stack symbol, right? So in this case, simply you should explain that the important point is here, that is the transition function. So just you should explain it in detail. So how it works? So just you can write here the transition functions, that is 1, 2, 3. One is associated for the variables, and another one is associated for the terminal, and third one is also associated for the terminal. So this is the simple way to convert a context-free grammar into PDA, or simply find the equivalence of, or you can say the PDA equivalence of the context-free grammar. So I think it is clear to all. If anyone has any problem, then you can discuss with me. Now, this is the another problem. For this problem, on the basis of first one, just you have to find PDA equivalent. So no need to think over it. Just these are the production of the grammar. Just you have to convert these production rules in the form of transition function. So just because of you are going to find the PDA equivalent from the given grammar. So simply the production rules are given to you. But the important point here is you should know, after seeing the production rule, that what are the variables and what are the terminals. So suppose if I talk about the production of E, then you will find here this I is the variable, this E is the variable, and any other there is no one, right? So this now there are only two variables are there, that is E and I. Clear? But if I talk about the terminals, then you can find here that star is a terminal, that plus is a terminal, open bracket is a terminal, close bracket is a terminal, 0 is a terminal, 1 is a terminal, B is a terminal, and A is a terminal. So number of terminals are A, B, 0, 1, open bracket, close bracket, star, asterisk, and plus. So these are 8 number of, there are 8 terminals used in the production, but there are only 2 variables. So now how can we convert it in the form of PDA equivalent? So by using the previously, by using 2 previous rules, that is this one. So this is the rule for all variable. This is the rule for all terminal. So by using the rules, these 2 rules, just you should convert these production rules in the form of transition function. So just try it. I'm just going to try. In this case, just first we will try to convert the variables. So in case of variable, just we can start with Q and null from the tape side. And in this case, just you should write the name of the variable. So first, there is the variable. So we have to write the production rule for transition function for E. And another one is I is also a variable, so we should write the transition function for I also. Clear? In this case, you can see now this E is producing I, E asterisk E, E plus E, then open bracket E, close bracket. So just how can we write? Just we have to write all the productions that are produced by E. So that is Q, comma I. Another one is Q, comma E, Q, comma E, asterisk E. Another one is what? Q, comma E plus E, Q, comma E plus E, Q, comma E plus E, right? Another is Q, comma open bracket E and close bracket, right? Is it okay? So these are the production rule for E. Now, similarly, just we have to write the rules for variable of I. So in this case, just you can see I is producing A. So just write here A. Another one is Q2 B. Whatever produced by this variable, you must write here, right? Another one is Q, comma IA, IA. Another one is what? Q, comma IB, IB. And another one is what? That is Q, comma what? Q, comma I0. Another one is what? That is Q, comma I1. So all these are the transition function for variable. Just all these are separated by comma. So just write here comma also between these. Clear? So these variables are completed because there are only two variables in the production rule. Now the same thing is written for the terminals. So in case of terminal, as we know, for A, we know very well what we have to do. And similarly, just we have to write for B also, because B is also the terminal here. So B here, just in place of A, जो मैंने rule आपको बताया, in that place, in place of A, just you have to put only B. So just you can find here, this is Q, comma null. And similarly, others are other terminals are A, B. It is okay. 0 and 1 also terminal. So simple, 0 is there, then 0 is there, then simply Q, comma null is there, right? Another one is what? Another one is this Q is there, 1 is there, 1 is there. Then simply means we have to write for all the terminals on the same way, right? Another thing is, other than this, Q is there and open bracket is there, right? And open bracket is there. Then Q, comma null. And another one, because open bracket is treated as terminal. And last one is Q, comma close bracket is there and close bracket is there. Then simply Q, comma null. So this is the simple way to convert the production rules in the form of transition function. Now, finally, after converting it, just you should write the complete PDA. How can we write the complete PDA? Means just you have to represent all the 7 tuples here, right? So you can write here all the set of states. So set of state is nothing, it is just Q. So just write here Q, it is there. Terminals, what are the terminals here? So you can write sigma here, where sigma is what? A, B, 0, 1, open bracket, close bracket, asterisk plus. And tau is what? That is the variable or terminal, union of variable and terminal. Transition function, Q, and start symbol S, where transition function works as this one. You can match the transition function with this one. This is the complete answer. You can match. I have already solved the question step by step manner so that you can understand easily, but you can match the answer with this question. This is the simple the variable. Just write all the productions of that variable, that is E. E is producing I, E asterisk E, E plus E, and open E. So, but there is one mistake in this question. Just in this place, you should write here this one, Q comma, right? This is the only the mistake in this question. And after that, I is producing A, B, IA, IB, I0, I1. So all these are the productions of this I variable. So these two productions are associated with only the variable, and rest of the productions are associated with the terminal. You can find here A is the terminal. So in this place, just we have to write the value of terminal. B is the terminal, 0 is the terminal, 1 is the terminal, open bracket is the terminal, close bracket is the terminal, asterisk is the terminal, and plus is the terminal. So total number of terminals are 8 here. So you must write all the transition function for terminal. So this is the simplest way you can say to convert, to find the PDA equivalent as per the context-free grammar. If you feel any confusion, any doubt, then we can discuss it in detail. If anyone has any confusion, so this is the simple rule. After finding the transition function, you must write the complete PDA also, because PDA is represented through 7 tuples, while a grammar is represented by using 4 tuples. So simply, this important point is simply transition function, because the working of any PDA or any machine is explained by using the transition function. And another part of is PDA to context free grammar. We will discuss later on the next lecture. For today, I think it is more than sufficient. If you feel any confusion, any doubt in context free grammar to PDA, then please let me know if anyone has any confusion. Okay, so simply these are basic 2 rules that you have to apply on the grammar, and after this simply you can find the grammar. Just initially, just I am recapping the things. Just find the variables and terminals. So apply the first rule for the variable and another rule on the terminal. In case of the variable, just you have to write the variable in place of stack side, and in place of input tape, just you have to write the null. And on the right hand side, you must write the productions or that are produced by that variable, simply nothing else. In case of the terminal, just you have to write both terminal in place of input tape as well as in place of stack side. In the both the cases, and the right hand side, you should write here Q comma null. This is for the terminal A. If there are more than one terminals, the same process will be repeated. If B is also a terminal, then in place of A, just you should write B. If Z is there, then in place of this one A, you should write Z. So these are the basic rules for converting context-free grammar to PDA. One for variable, another for terminal. If more than one variables are there, then the same thing is repeated again and again for all the variables, right? In place, suppose A is there, then we write here this one. If suppose A, B, C, there are 3 variables, then you should write 3 rules, 3 transition function, one for A, another for B, and another for C. So I think you should learn how to find the PDA from the context-free grammar. If anyone has any doubt, please let me know. Anyone doubt? Anyone has any doubt? Please let me know. Okay. No problem. So tomorrow we will start PDA to context-free grammar. So for today, I think it is more than sufficient. Thank you for attending the class. Thank you, and do your exercise properly. Thank you.